Welcome to Valuistics Part 4, entitled Statistics. I'm David Braun. Let's review what we learned in Part 1, 2, and 3. In Part 1 we discussed that we are trying to identify proven statistical methods and techniques to add to our valuation methodology. In Part 2 we identified some of the criteria that AVT uses to decide if a specific statistical method or technique should be used by appraisers at this time. In Part 3 we discussed what a database is and what a spreadsheet does. We also discussed some of the things real estate professionals can do to begin learning more about these tools. Statistics pertains to the collection, analysis, interpretation, or explanation and presentation of data. This is a very general but appropriate definition for statistics. Now wait a minute. We just said that in statistics they collect data, they analyze it, interpret it, and then they present it. Now in my everyday appraisal practice, I do data gathering, I do analysis and form opinions, and I report my conclusions. So there's a huge similarity between the basic outline of statistics and what we do in appraising. There are some other additional overlaps. For example, an appraiser would say the adjustment amount, and the statistician would call that a coefficient. An appraiser would talk about market efficiency, and the statistician would talk about randomness. Appraisers will talk about comparable selection, and statisticians call that sampling. Appraisers do paired sales analysis, and statisticians typically do their very similar analysis with regression analysis. Appraisers call an error for the difference between what something is and what we predict, and in statistics they call it a residual. So there's a tremendous amount of overlap already in what appraisers do is comparison to what statisticians do. Statistics is a huge field of study. Many different industries use specific statistical techniques that have been tweaked for that specific industry. We looked earlier at this slide in an earlier presentation that many industries have used statistical methodology and techniques to help them in what they do. And you can see some of these. In a traditional form, in the early 1900s, the traditional field of statistics served as a tools for states to gather information about the respective population. The intent was to have this data so the governments could make long-term plans based on the needs of the population. Let's look at a hypothetical example. Let's say around 1915 the state of Tennessee wanted to know how many children there were in each county so they could plan on where to build schools. The only way that they knew how to do this was to locate each family and ask them how many children they had. This would be a daunting task, especially in the rural areas. However, statistics came to the rescue. Statisticians professed that with sampling, that would allow them to form a reasonable estimate based on the number of children and their ages when the overall population is known for each county. All that was needed was to find out how wide the distribution of children per family was. Was it, from 0 to 12? Was it 3 to 7 typically? And also to determine if the sample was in fact a mini version of the population. And we look into a Gaussian distribution to help us determine that. So the amount of dispersion could be measured by something statisticians call standard deviation, a statistical measure of dispersion. The bell curve is a graphical representation of the normal tendencies of a sample or population. You've seen this picture in some of your textbooks, and on the bottom are standard deviations. And what these type of bell curves try to do is show how much of the population is within, for example, 1 standard deviation, and how much is 2, and how much might be in 3. The Gaussian distribution, simply put, if you know the sample size, the results of the sample, and if the sample size was large enough to conform to the normal bell curve, then inferences can be made about the number of children per population for an entire area, like per county. So the results of this statistics, it was not necessary to interview each and every family. Only a sample of the population had to be interviewed, which would be accurate enough to plan where schools should be built. So Carl Friedrich Gauss, it would be difficult to overstate the contribution of this 18th century mathematician to the development of modern societies based on this one contribution. But wait, he did even more for evaluators in his contribution to the development of an analysis technique called regression. So to learn more, take the Appraisal Institute seminar, Real Estate Finance Statistics and Valuation Modeling. Thanks.